Hey everyone, welcome to our professional STEM shadowing event with Thomas Chen here. This is hosted by AHS Inc. Team Ink and Metal. My name is Ashi Malik and I'm an outreach member from the team, and we would like to introduce our speaker and begin this event and how it'll work. Let's start. Neha?
So Thomas Chen is an optical engineering major at the University of Rochester who graduated from Irvington High as a team leader in the school's robotics team. He also mentored Horner Junior High School's VEX robotics team and has also worked on numerous projects involving 3D printing and designing, and is currently pursuing a career in mechanical engineering.
All right, thank you so much. Hi everyone. I'm slightly sick, so you'll have to bear with me throughout. I am Thomas Chen. I study at the University of Rochester, and my major, or my formal major, is optics. So that involves anything with the three L's: light, lasers, and lenses. Essentially, you can think of applications in AR, VR, especially the panels that are used to project images and the lenses themselves, things like glasses, fiber optics, and the whole wide range of everything that involves everything and in between. So last summer, I worked at an internship at a lens manufacturing company, which is one of the major lens manufacturers. And as a fun fact, some of their lenses are actually on Mars right now. I went to Horner and Irvington High School, which is neighboring to American. And for my junior and senior years, I went back to Horner Junior High and coached many robotics teams over those 2 years. And I know many of you who are joining in today are very likely STEM oriented. And if things were very similar to how I remember things being, I know there are a lot of people who are doing computer science and starting to learn code, but there was a disconnect in terms of sort of code and computer science and then engineering itself. So today I want to sort of provide a perspective on one of the most valuable skills, in my opinion, for engineers, which is computer-aided design. And I hope that at least by the end of this sort of presentation or demo, that I can at least convince you or let you see why it's such an important thing to know. So to sort of start off, before we start, it helps a lot if you're trying to follow along and you have an actual physical mouse with you, because working with a trackpad gets a little difficult when you're trying to move in 3 dimensions. And if you haven't already, it'd be great if you could set up a Tinkercad account. That's what we'll be using to actually do some demo models, and I'll show you and walk through the process with you then. So just to get a head start, if you haven't already, you can create an Autodesk account, which will allow you to access Tinkercad. So as a really brief demonstration, CAD is a tool that we can use to really turn our ideas into realizable goals and tangible products. So you can think about turning a bunch of sketches that you might have and producing drawings, and then these drawings can then be formed into a 3D map of something that you can actually use to create. And this is very, very important in things like rapid prototyping, 3D printing, documentation, and in general, just manufacturing in its entirety. When you see the fancy Apple commercials where they have the expanding laptops with all the parts coming out and then fitting together, all of that originated in some form in CAD, and then it was probably thrown into sort of circuit design and manufacturing tools for actual production in factories. And then the demo marketing products that you actually see on your screen in the commercials are thrown into a render engine that allows you to produce these really amazing and like these very sort of detailed animations of how things are put together. So I'll start off, and today we're going to be using Tinkercad. So Tinkercad is a really beginner-oriented program. It's not really what we would consider a full-fledged industry sort of CAD program. And I'll be demonstrating some of the actual sort of industry techniques and actual programs like Autodesk Inventor and SolidWorks at the end of this demo. But I just want to start off with Tinkercad because it's a really good tool that allows you to sort of get a mindset of how CAD works and how we can sort of apply shapes and sort of combine geometry to make objects that we see in real life. So by doing this, I'll start off with a demo, and I'll be actually showing, walking through a process of building something like a model train. So for those who want to go straight ahead and just start, the base model that I'll be basing this off of is this train model, which is designed by ZZ Simmons. You can just go on Google and type in Tinkercad train, and this is one of the first things that pop up. And we'll be using some of these sort of shapes in this design because we don't have the full time to actually go through and break down all the shapes inside a train to actually model it. But we'll be using this as a base for us to actually design the parts from. So I'll first go ahead and log in. So going to Google, and then yeah, for those who are really interested and do want to learn more, there's also a lot of educational tools that you can use in Autodesk that allow you to follow tutorials and learn other sort of demos that they might have. So this is just something that I've sort of created on my own. So yeah, let's let the program load. All right, so as you can see here, there's buttons that allow you to learn other material. So if you follow this, you can go and actually follow some other tutorials that they might have that you might find interesting, such as I believe they even have some code-based 3D modeling as well. So those things can get pretty interesting if you're if you ever want to try something like this. You can go ahead and start one of the lesson plans that they might have. But anyways, I'll start with a train tutorial. And I'll just tinker this. So for anyone starting new, you can just create a new page, just start a new document, completely brand new. I just have this as a reference to sort of memorize what dimensions I had for objects. So, all right. So just jumping straight right in, this is your interface. And what you'll see is actually, just to make it easier, I'll go ahead and actually make a new document. That way you guys can actually see everything just the way that I can. All right, so you just click create a new design up here. And then so you'll see, you'll open up with a workspace with a project title, and you can change this obviously later. On the side here, you'll see a bunch of sort of shapes, and these are essentially our building blocks for our model that we're going to sort of decompose and use to put together something else. We have 3 tools up here. This is the comment tool or notes tool to add little notes wherever you need to. This is the ruler tool, which allows you to essentially dimension parts. So you can label the specific lengths and widths of parts so that you can get accurate measurements. And this is the work plane tool, which essentially defines the plane that you'll be working in. And over here, you'll see this 3D sort of cube, and this just defines the plane. So if I click on this side, I can move to the top, I can switch to the back, and I can move to the bottom. So essentially it defines your model in 3D. And we can go back to the home position, which brings us back to our original view. Now, we can zoom in using these buttons as well. If you have a mouse, it makes things a lot easier. You can hold the left click and it'll rotate the page. If you hold down the middle mouse, it'll move the plane. And if you just do your regular left click, it just left clicks to select items. If you're using a touchpad, it becomes a little bit more difficult. 2 fingers is scrolling. So if you're moving your fingers up and down or on the trackpad, you can zoom in and out. If you're holding shift and you right click on your mouse pad, you can move. So I'm moving up and down, as you can see, or around the workplace. And if I just hold the regular right click, I can rotate. And as usual, left click is to select. So that's just the general sort of form of how you can actually use the interface and move around essentially like a 3D world or map of the model that you're going to be working in. All right. So I'll start off by, for anyone who's following along, we're going to essentially be following a sort of methodology of breaking down a complex thing into different shapes. So if we see here, this is a train, which again, you can download from the model, which I had earlier. And it's made up of a few key components. We can see a sort of rectangle square prism in the back, right? A rectangular prism. It has this sort of curved arc on the top. And we can see another rectangular prism on the bottom. And this main 2 part is composed of a cylinder. the smoke pipe is consisted of cylinders as well as a sort of cone with the top cut off. So these are all shapes that we can make and break down. We can break down this really complex model into really simplified shapes that we can use to create this train. So I'll start off by first using the measure tool just to make sure I know what dimensions things are. So if we click on a model with the ruler tool enabled, it'll give us all the dimensions. So I can select it and click on something and it'll tell me the heights and widths of parts. If I click on it again and again, it disables it, so it goes back to its normal shape. So what we should do is we should start off. I'm going to just quickly check. This is a 10 by, so it's 20 by 20 by 10. So I'm going to start a new document and I'm going to drag over this sort of dome shape. And I'm going to specify the lengths of this object. So I'm going to click on the ruler tool, just make it easier for me. So this is 20 by 20 and this is 10, which I believe should be the exact same as what we want here. So this is all correct. We can just leave it on the plane, on the work plane. And then we can start off with the sort of red piece right here. This is a 20 by 20 by 25 sort of rectangular prism. So I'm going to drop this here. I'm going to set these distances to 20 by 20, and the height should be 25, right? And then I'm going to move this somewhere in the middle so that I can easily access it. I'm actually going to minimize this so I just don't see it. Okay, and then I can drag it over, and I'll just place it somewhere near on top of this, and then I'll actually move it back a little bit. And then using the work plane tool, we can actually define an area where we want our planes to start at. But all I'm going to do is essentially, I'm essentially just going to, let me make this a little bit easier to see. To edit parts, you have these little dots that I can click on that stretches things. So you can move it out and it enlarges the shape. You can click on these and this will make the height higher. And you can also click on it and drag it around the plane. But if you want to move it up, you have to click on the arrow right here. And this will allow you to bring it up in position. So we can put it at the proper height. So I'm just going to go back to the original model and take a look. So this shape right here is a 25 by 25 by 5. So I'm going to start. Okay, how do I close the top bar? I can't see what I'm doing. Okay, so I'm going to do a 25 by 25 by 5 shape on the bottom. So I'll start on the base and we'll work on clicking on the ruler tool again. We're going to click on this. We're going to make sure that this dimension right here is 25. We're going to make sure this dimension over here is also 25 and that the bottom is 5. So this height right here is 5. And now here's our base. And we can give it a nice color. Something like green would be fine. And then we'll move it into somewhere around the center just to give it a nice position to stay at. And then now that we have this shape, we want to put this shape on top of here. So what we can do is we can click on our work plane tool. You can actually click on it, and then we can select this top surface as our work plane because we want to put this red rectangular object on top of this one. So we'll click on this, and then it'll move the plane up to this field, as you can see. So it's on top of the surface now. We can drag this up, and you'll see the height go from -1 to 0. So now it's perfectly flat on the plane. And then now we can move up, and then now we can drag it onto this board. Now we want to align this so that it's properly centered. So what we can do is we can click on the first object, we can hold the shift, and then we can click on the second object. Doing so brings up this option right here to align the two objects. So we can click on this tool, we can click on the bottom shape, and we can align in the middle and in the center. So now it's perfectly aligned right in the center of the shape. So it's perfectly in the middle, and these two shapes are perfectly attached to one another with the centers aligned. All right, and then we're going to move this part. We're going to change our workspace again. We're going to click on this top surface, and then we're going to bring this shape up as well until this height becomes right here, becomes 0, because we want this to be flat with the top. So now that this is at 0, we can drag this over, and we can do the same align tool trick that we did earlier by just clicking on the align tool and then selecting this surface because we want to put this blue part on top of here and then aligning it to the in both directions so that it's centered appropriately. So now we have our general shape. I'm going to click on the work plane tool and drag it out. and just click somewhere out. Okay, one sec. Yeah, drag it out, and then now it's back to the original workplace that we started with. So this is our ground floor. And then now we can start off by working on some of the other elements. So if you notice here, these two parts have holes in them, which means that we need to remove or subtract some part from the shape. So to do that, we can essentially go right here, and then we can essentially add another shape to this shape that will allow us to cut we can put a shape inside that can act as a sort of cut or a sort of hole, as you can see on the screen. So I'll drag a shape in like this, and this is one that's not textured, it's considered a hole. And then if I put it at the center, so I'll go ahead and I'll align it with this shape. So we'll select both of them with Shift, and then I'll make sure that both of these are aligned. So I'll click on the surface and make sure that this is here, and this is here, and that this is here. So it's perfectly in the center. I can scale the shape by, and then I can expand it in both directions by holding Alt. So if I hold Alt, you can see that both sides will expand in the same direction. And then now I want to shrink it on these sides because we want to create the hole. So I'll click on it again, and then I'll shrink it like so. And then we can make these dimensions something like a reasonable number, like 18. And then I can make this probably around 30. So now when I group this object with this object, and I group these two together, you'll see that it automatically cuts the hole out of the shape. So now we've just combined two shapes, one which we considered a hole and one we consider as a solid object, and now the inside is subtracted, which is what we want. Now, to do the same thing for the top, we can actually make it even easier. So what we can do is we can actually just duplicate the model. So now there's another one on top, as you can see. And I'm going to go ahead and scale this model down. So I'm going to first expand in this direction because we want to cut out the inside. And then I'm going to scale down center-wise. So I'm going to click on the center, hold Shift so that it's scaled, so that it scales properly with its dimensions. And then I'm going to make it smaller. And then I'm going to move it up about 1 so that we can get a little bottom part right there. And then I'm going to scale it back down because we don't need it to be so large. So somewhere around there is probably fine. And then now we can designate this shape as a hole. So we're going to make it a hole. And then once we group these two objects together, we cut it out. So now we have our exact two shapes that we're looking for, with one with a top cut off and one with the center of the rectangular prism cut out. So that's this part. And now we can work on a wheel. So a wheel is one of the actually more challenging parts of this build because as you can see, it's made up of around 3 different shapes. We have a toroid, which is like a donut shape on the outside. We have a cylinder on the inside, and then we have another cylinder as a sort of peg for the wheel. So going back here, I'm going to scroll down until I see this, which is the torus, and then I'm going to click on it. We want this to be defined as a solid, but it's currently a little bit too large, but we can always scale it down afterward. So it makes it a little bit easier if we work with the larger size models. We're going to go ahead and drag the cylinder in, make it a little bit smaller. So the height has to be around 1, I believe. And then we want the other dimensions around it to be smaller than the size of the torus. So I'm going to make this 15 or so, and then make the other side 15. All right, I'm going to drag it across. And now that's there, we can go ahead, we can select these two shapes, and we can align them. So I'm going to select these two. And I'm going to hit the Align tool. And this will allow me to align first in the Z-axis, so I can put this cylinder in the center. And then after that, I can align it in both the X and Y direction. So now it's perfectly centered, and now we have the center part of our wheel, and we need to add the middle part, which is the spoke. So we can do the same trick that we did for the top, and we can duplicate this shape. And now it's directly on top of it. We can hold Alt and Shift, and that will allow us to scale through the center. So now it's essentially scaling to the center point. If I let go of Shift, you'll see that it's going to scale to the corner instead. So I hold Alt and Shift, and then I select these 2 points, and then I drag this in. And now it's getting smaller and smaller. We can now keep holding Alt and let go of Shift, and then drag it out. So now we have a little spoke. And we can change the dimensions on each side. I'm going to make this around 2 and 2. There we go. Oh, it became misaligned, but that's fine. So we'll just click on this, we'll click on that, I'll align it, and then make sure we're aligned there and just right click it there. All right, so now that this is centered, we're going to make it a little bit smaller because it doesn't need to be that large. And I'm going to change the shape to something that's a little more reasonable for what a car tire would look like. So I'll change the center right here, and then oh, remember what? Okay, let's make the wheels gray, and then we'll make the center black. All right. So before I continue, does anyone have any quick questions? I'll take a look in chat as well. Okay, so nobody has any questions? I'll continue ahead. All right, so now we have our wheel. And yeah, I do know I am going a little bit fast, but this is a pretty long tutorial. So I just want to get as much as I can done in this period of time, and you can feel free to pause it and watch the recording later. So now that I have the wheel done, you can see it's a little bit large. So we're going to hold Shift and we're going to scale it down. And once it's scaled to appropriate size, we're actually make it a little bit smaller. We can rotate this surface 90 degrees. So holding Shift allows us to move in 45-degree increments. So now I can move it to a 90-degree position, and select all of this and just drag it over to somewhere around here. So we'll keep that for there, and we'll actually sort of put it in a better spot once we've designed everything else. So this is the initial part of the back end of the train. So we're done with that, and now we can work on the front. And the front composes mostly of just one single cylinder, so we can make that pretty straightforward. So going over here, I can click on the work plane tool and select the surface, because we want the cylinder to start off on this base surface. So dragging it up, you'll see that it matches perfectly with what we want, and it fits right there. We can extend the length, so we can make this around 30, I would guess, somewhere that's pretty reasonable. Maybe a little bit longer. 35, we'll do 40. All right, and again, it's not aligned to the center of this red sort of prism, so we can select both, click the Align tool, and center in the middle. So we can put that in the center there, and then drop that somewhere over there. Oops, I don't want to move that, so I'm going to click on that. Tool, make sure it's aligned to this surface, and then click on here, and then click on here. So make sure you clicked on the, you always click on the right surface that you want the next, or the surface, you make sure you define the surface that you want to move and the surface that you actually want to stay in the same position. So now it's perfectly aligned, and I can go ahead and click on this and drag it out. So we move our workplace back to the original plane. And actually, I'm going to drag this down a little bit just so that it fits nicer as a train. So I'll put it around there. Okay, and this is our sort of tube part of our train. And I'll just give this the same color as the original part of the train. There we go. So now we have this main tube part of the train. We can go ahead and add this sort of front part, which is right here. And this will be essentially very similar to how we built the cylinder earlier. All we're doing is we're adding a work plane to the surface right here. And we're going to duplicate this, just to make it easier, we're going to duplicate it. And then we're going to move it up, probably around here. Now it's zeroed. And then we're going to make it smaller. So we're going to make this around 1. And then we'll change its color to something like gray. And then we're going to duplicate it again. So I'm going to go ahead and duplicate. I'm going to hold Shift and Alt again so that it scales while it's moving down. And I'm going to move it to somewhere like that. And we're going to move it up 1, so it pops up. And then I'm going to make this something like orange. And then just to add another one, I can duplicate and repeat again. I can hold Shift and Alt so that it scales down. And then I can bring that part up a little bit. And then I can make this yellow. So there we go. We have the center of the train designed. I'm going to drag the workplace back and drop it on the floor. So we have our sort of middle part of the design complete. Now, this part of the shape might look a little bit daunting to work with because it's not really a general shape that you're sort of familiar with, but the overall design is not too tricky. It's essentially a pyramid. So we'll go ahead and we'll drag this pyramid shape somewhere down here. And we notice that this side over here is flat. So this part is flat and this part is slanted. So what we can go ahead and do is we can click on this shape and then drag it until this part is flat, like around 5. That's flat. And then we can extend this part out to give it a little bit more of a turn. We're going to move this part of the center out a little bit. So I'll bring this down actually. And then we can move this across. So I'll extend this and then we'll move this accordingly, like so. Okay. So and then I'll drag this probably somewhere around there. It's probably pretty good. I just want to make sure if I can. I think 5 is pretty good. Okay, so 5 is about all we're going to get. So I'll move this across and then scale this part down a little bit. And then I'm going to move this back so that it fits in the bottom of here. And as usual, we can always scale these parts. So we can go ahead and make sure that this is aligned to something like the bottom. So I'll click on this component, which is the bottom base, and I'll make sure it's centered. So I'll select this object and just make sure that it's centered in the middle right here. There we go. Now it's centered in the middle of the train model. Yeah, you can also cut things out if you wanted to, but it's hidden under this shape. So when we group it all together, it doesn't really matter that the top is cut off. But if you wanted to, you could add another hole and you could put a cylinder on top of it to cut this top of this shape off. But because it's already intersecting with the model, it doesn't really matter. So now that we have this sort of bottom designed, we can go ahead and we can now model the top, which is the sort of smokestack. And this is made up of 2 cylinders. I'll simplify it and make it 1 cylinder. So I'll go ahead and click on this shape and then drag it to the top. Let's use something smaller. So I'll go ahead and click on Shift and scale it. So it scales in all directions accordingly. So we'll do something like 5, and we'll extend it up. And then I'll go ahead and move it to the center. Oops. Move it to the center. Move it up. And then move it over around there. And then I'll align it again just to make sure that it is actually centered. I'll click on this surface and make sure. So it is already centered. And we can just adjust the height a little bit so that it matches better. Okay, so now that we have our part that's protruding from the smokestack, we can now get this inverted cone. So we can grab a cone and then invert it. So we can change the direction. We'll click on this side, and while holding Shift, we can rotate it in 90-degree increments. So we can 45-degree increments. So now it's at 180 degrees, and we can move this somewhere above. Well, actually, let's scale it first. Maybe around 10. And then now we can drag it back down and then move it up like so. And to align it, we can click on both surfaces. We can click the Align tool, select the cylinder because we want to move this to the cylinder. And then we can click on this point in the middle, which will align it in one axis and then align it in the other axis. So now we have this part of the smokestack done. And then now we want to add the top surface. And because this is flat, I'm just going to click on this and we're going to move the work plane onto this surface. We're going to drag the cylinder on top. We're going to change the shape. Something like, I believe this was 10, but just to check, we can click on the ruler tool and check this, check the width of this. So this is actually 10. So this is 10 too, great. So now we can go ahead and move this to the top and just match it up in position. If we can't, we can always align it, but something like around 3 and 4. I'll click on this surface and this surface. I'll click on the Align tool. I'll select the bottom surface, and then I'll align it in the middle, in that direction, and in the middle in this direction. So now it's perfectly above as well. And then I'll make this all the same color or maybe make it a little bit fancy in color. Put something like this, and then grab something like this, and then like that. So that's a smokestack, and then I'll drag the work plane back to the floor, reset it. It wants me to. Okay, well, there we go. All right, so now we have the basic model almost done. So this bell right here is actually designed from essentially a sphere with a torus on the bottom and a little sphere on the top as well. So if you wanted to, you could design that, but these are pretty small parts, so I'm not really going to worry about that. This part is just a simple rectangular prism that I can stick on the side, and I'll go ahead and finish up the wheels. So what we can actually do is, so I want to select everything here. Click on this, and then, okay. I'll select these 3 components if it'll let me. Like these 3. There we go. And I can move this up maybe a few centimeters or units, and then maybe around 2 or 3. So it's lifted up the ground. So it doesn't seem like it's stuck on the floor, because that's where the wheels go. And we're going to move this so it's flat on the ground. There we go. And we'll move this over to around here. And we'll scale it down actually, just to make it a little bit smaller. And we'll move it across. Somewhere like here. You put 2 wheels if you wanted to. I'm just going to do 1 for now, just to make it simple. Put one around right there. And then I'm going to actually select everything again. And we're going to click it right there. And then I'm going to use this tool again, which allows me to duplicate and repeat. So I'm going to click on this, and then we're going to drag this over here so that it matches up on the other side. And we can make sure the bounding boxes are about the same, so that they're in the same location. I believe that's spot on. All right. And then for the front wheels, we can go ahead and duplicate this again, but I'm going to actually increase the size. So the front wheel should obviously be larger. And we can make something like that. Actually scale it down a little bit. Oops. This way. There we go. And then we can move this to the front area of the train. Well, it's probably a little bit too big, but it's probably fine. So I'll move this on the side here. And I'll duplicate it again and repeat. And we'll drag it over to the other side. And you could probably spend a bunch of time and sort of fix things up, make the wheels look a little bit better, because they're a little bit large right now. But other than that, you can sort of follow the same sort of steps that I applied in actually putting it together, the train. And many of the same steps that I used will be the same for what you inevitably end up doing. So yeah, this is essentially, you can essentially find other versions of this. You can do other sort of tutorials that Tinkercad has, but either way, there's a lot of sort of methods for you to actually apply and sort of build these designs. So some cool stuff that comes with Tinkercad just to sort of visualize your work. I'm going to go ahead and quickly scale this entire model up by around maybe up to 100, just to make it really large. So if you go ahead and you can actually drop these models inside a Minecraft viewer. So in case if you actually wanted to build something really, really complex, it actually shows you the breakdown of how sort of blocks work. So if you wanted to, you can actually build the entire sort of train or whatever 3D model you create inside something like Minecraft. Or if you wanted to build it out of Legos, you can change the scale. So I'm going to have it here probably be the largest, which is the most detailed. And then you can actually go over here and see it actually be created out of Legos, which is really, really cool. So you can actually build these parts on your own, which is, in my opinion, very interesting. So yeah, there's also other tools you can play around with. So if you want to add train tracks, you can find a model and you can copy and paste train tracks. If you wanted to, I don't know, add a mountain or something, or trees, you could put a mountain on nearby and scale it up and just give yourself some nice scenery around the edges so that when your train's passing by, you can see a move cross or something. But yeah, either way, this is a sort of Tinkercad is definitely more geared toward is more designed for sort of 3D 3D sculpting and modeling rather than specifically CAD. But it's just a really good way for you to sort of get started with modeling in general. So now I'm going to kind of switch gears and actually talk about what I do on a daily basis in CAD and how this sort of differs from this, but applies the same principles that you might see me use in this train design. So, all right, I'll give a few minutes for anyone who is currently finishing up to save things, and from there, then we can get started on the second part.
That was really cool. Thank you for that demonstration. I learned a lot and I'm definitely going to apply it later.
That's nice to hear. Thanks.
Anybody have any questions they would like to ask right now?
Oh, I saw a message in chat. Can this be 3D printed? Yes, it can, but there are a few caveats to that. But most of these models, as long as you design them correctly so that the shapes are sticking together. So like, for example, we made sure that this smokestack is actually inside this shape. If you put it above, if I put this like above and don't actually fully merge it to the bottom, like if I put a gap or something, well, if I put a gap in the top here, like even if it's a millimeter wide, it's not going to come out correctly because you just have to make sure all of your model is connected together into one piece. But 3D printing is a great aspect about that, and I'll talk about in the second part of my sort of tutorial. Is there any other questions? All right, so if there's nothing else, I'll go ahead and actually show you what I normally do on a daily basis. And this is a much more advanced version of just putting shapes together. So recently I finished an internship at a lens design company, and my task was I was in the test engineering department, and I worked in automation of essentially systems that would allow me to test lenses. So my job was to build a robotic arm that could pick up components from a sort of tray and then move them to testing stations to actually be used in testing of the quality of the lenses. And if the lenses were of good quality, then they could be moved to another station. If they were of bad quality, then they'd be put in another location. So my job was to design and code and actually build it. And let me just skip all this. So this is Autodesk Inventor. If you've ever worked in robotics, you've likely used Autodesk Fusion or Inventor. It's the sort of manufacturing or industry-based program that you use.
Sorry to interrupt, but we cannot see Autodesk right now.
Sorry. Yeah. All right. Okay. Sorry that. All right. So I'll share Autodesk Professional. So as you can see here, it's a lot more complex. I have a sort of screen on this side that shows every single one of the parts that went together to build this robotic arm. And it's extremely complex, full of multiple parts. So this is an assembly, and I can actually go into sort of a specific part and I can actually open it. And you can see that this model itself is built from a bunch of little tiny parts that are created with a bunch of sort of features that you would normally, you would start with essentially sketches and then build these up into 3D models. So for example, one of the main benefits of CAD is that it allows you to sort of simulate real world applications and movements before you actually build it. So in this model right here, which is the claw, I can make sure this is not constrained. So I'm going to set this degree to not 0. And I can actually go ahead, and since this is all constrained together, I can actually move the arm and you'll see everything moving in sync. So this is a servo motor and it's driving the robot arm to open and close. And you can see that real time by me moving one of the sides. Unless I move it too far, then it breaks. But you can sort of get the idea if I put the limits on it. So this is one of the really cool ways you can sort of graphically demonstrate something. And I can go ahead back to the model, and you can see all the really nifty and like specific components that actually go into this, from the control board inside to the fans, which are signed and modeled here, to the gears and the actual components that do the motion systems, to the motors, to the bearings and all of these sensors that go on top of it. So if this doesn't crash on me, nice, okay. can also see all the mounts and all the other components that exist on this model. And I'm hoping that this was around a 10-week project. The original design, this was a branch off from another design that I built. So the model initially was not completely built by me, but I did all of these modifications to it to make this 3D printable. And I'll actually show you. So this is just the CAD model that I designed, but the final product was actually 3D printed. And if it'll load, which might not. Give me 1 second. All right, no albums. Okay, and then let me go over here. So let me stop sharing or new share, and then I'm gonna share my screen. So if you can see my screen, I have a picture coming up, and this is the actual physical arm produced in real life. So all of these parts are 3D printed, which I've just shown here was originally designed in CAD. And then here's all the wiring with the PCB mounts and the motors and the servos, as you've seen with the movable claw. And obviously there's a lot of behind the scenes parts as well, which comes in the code design and the firmware changes and manufacturing sort of deploys themselves, doing soldering, wiring, testing, all that stuff, calibrating. There's a lot of stuff that goes into this, but you always start with CAD. CAD is the first thing that you'll always work with. And it's a great tool that allows you to build things like this. For any of you who are doing robotics, who are doing documentation, here are some of the documentation sort of CAD models that I made a few years back. It's been quite a long time since I've actually come back to these images, but these are some of the initial designs when we were using to actually build our sort of forklift system. So this is like a 4-bar, I believe. This is an expanding wheel that we can move in and out. Here's the motor mount for that, so it's connected. Very, very useful for documentation and prototyping as well, to make sure you get your dimensions right and to make sure that these things actually work before you try them. So we have a system of gears that move together to move the top parts up. We also have systems where we can link parts together. And it's also great for documentation. I can color which parts do what and how we need offsets in certain parts, like we need a washer here in order for this part to fit, other things in general design. So this is for VEX EDR robotics, and connectors and angles that we need to be specific of and how much stress these plastic parts can hold, and the angle range and the height extension that you can get for all these parts. And this is such a great way to do it beforehand in software before you actually go ahead and build the entire thing and then realize it doesn't work. So figuring out the degrees that we can actually move things and actually sort of orient the components and how the motors will move beforehand is really an important part of obviously how your robot functions. And if your robot can't do that, then it's a lot easier to fix that in CAD than rebuilding the entire system. So this is just one demonstration of that. And I guess since we still have a little bit of time, another cool thing that you can do. So I just created a new part right now. I'm going to start a sketch. I'm going to create a surface, and I'm going to go ahead and just create a rectangle. So this is a really simple part that start over here and make this, let's do something like 20 by 10. And I'm going to extrude this part up. I'm going to give it volume, and I'm going to give it probably around 10 millimeters of volume. So we have this regular simple cube, right? And you might be wondering, what's the point of this, right? So Inventor also allows us to do things like stress analysis. So we can see how forces are applied to different shapes. And this is really useful if you ever want to sort of manage how force is distributed throughout an object, just to make sure that it can sustain a certain amount of weight. So you can actually generate shapes too and sort of make things less heavy. So that's what I'll show you here. Just a quick demo of how you might apply something like this. So I'll start off with the material. I do not want it to be steel. That's way too strong. So I'll select a material. I'll assign something like ABS plastic, which is general plastic. And then I'll put a constraint. So I'll make this side fixed. So this side will always be, you can think of this as essentially attached to something. It's not going to move. And then I'm going to put a load on it. So I'll put a force, and I'll put a force on top of this surface, and I'll give it maybe, I'll just put 100. And then I'll put another force on this top surface right around here. and I'm going to put it in this direction. So it's moving downward, and I'm going to make it like 100 again as well. So you think of this as essentially like a bookshelf. You have this attached to the wall, and you have some object which is pushing down on the top. And we're going to preserve a certain region. So we're going to make sure that this region isn't changed. And we're going to select about that. That's probably good. We're going to preserve another region on the top here. All right. And then now we can actually go ahead and click on generate shape. And if it doesn't crash my computer, that should be great. Okay, I'm going to reduce it by around 40. And we're going to click on generate shape. And we're going to click on this.
Wow, this is really cool.
Yeah, this is one of the more sort of interesting aspects to it. Most of the time you don't do shape generation. Most of the time it's more building parts, but it's just something I like showing because it's really interesting to show how like these programs are really advanced in the way that you can sort of adapt stresses and forces and put that all together into one complete package that allows you to sort of view everything about your design. So this will probably take a little bit of time. Well, probably not too long. Let's hope it runs through. All right, can I do other stuff while I'm waiting? Okay, yeah, I can. So going back to my robot arm. Oh, don't crash. All right, no problem.
I may have missed out on this before, but when you were talking about the robot arm, what's like the function of the robot arm? Like what's it supposed to be used for?
Yeah, so it's essentially using a system that there's a tray of lenses, and they all need to be tested for quality, right? They have to be the manufacturers have to make sure that they're of a certain spec, that they're not scratched or damaged in any way, and that they're like of a correct curvature. So they go into this machine and they get tested. And once it's done testing, it's either rated as good enough and then it's put in a certain pile, or it's not good enough and they have to sort of polish it up and do other work on it to make sure that it's finished. So this process with a batch of like 20 lenses could take many, many hours because you're putting a lens inside a machine, it's doing all the tests, and then you take it out and then put it somewhere else. And it's a very redundant process of moving stuff and testing things. So by building a robot arm, you can actually automate this and have it move to the lens, the first lens, for example, pick it up and then drag it and move it to the machine. If the machine detects that it's good enough, it sends a signal back to the robotic arm, which tells it to move somewhere and drop it off as good. If it's bad, then the signal will be sent to the robotic arm and it'll move somewhere else. And then it'll do all this automated process of testing for you, if that makes sense.
Yeah, wow, that's nice.
Yeah, there's a lot of code behind this as well, but it was branched off of 3D printer firmware and whatever, but that's a story for another time. Another really cool thing that CAD allows you to do is it allows you to be adaptive. So when you 3D print parts, because you're using plastic to print, plastic is not completely uniform. It's depending on the type of plastic you use, depending on the environment, the humidity, your plastic can shrink and expand while it's cooling down, and your holes might not be the right size, and your shapes might not be the right heights because either the printer you're using is different or the material you're using is different. And by designing this part right here, I've essentially linked all of these holes that you see up here into the model. So all of these holes that are designed from the fans to these connectors are all linked to this part. So when you 3D print something, you can just print this model out, test it, make sure that all the holes fit with the right screws, the right nuts, the right connectors. And if it doesn't, just go straight in here, adjust all of these dimensions, and it'll automatically update on this arm. And that means that when you actually go and print out this model in your 3D printer, you'll know that all the holes are of the right size. And that's one of the really useful tools of CAD as well. So going back to here, please tell me it worked. And it's not showing me. Oh, well, that's fine. But let me see if I can actually change the study then. Study properties, and we'll do static analysis. And I will simulate. This should not take as long. So you can see here that, actually, let me change the range because it's pretty high. So I'll move this into, let's do like 70, 60. No, I need to bring it up and more, 20. Yeah, so you can see sort of, if I apply a load to the center and the very edge, you can actually see the force distribution and how some areas are experiencing the force a lot heavier than other objects. So if I move the shape, you'll see it bowing down from its original height. It's bowing down because we applied a force here, and you can see that force being spread out throughout. And its attachment to the wall position is also being affected, because at this position, when it's connected to the wall, it's experiencing a lot of force downward that's pulling it apart. And on the bottom, it's experiencing a lot of force, which is pushing it and compacting it. And you can actually get this very graphical demonstration of how these forces are actually interacting with your model, which is really interesting. Yeah, but overall, again, so there's a lot of uses for CAD. Tinkercad is a really good way for you to get started and for you to see if it's something that you might enjoy. But if you really find this interesting, if you love 3D printing, if you want to do work in sort of building and prototyping parts, definitely starting with Autodesk Fusion 360, which is free for students and makers, I believe. So you can sign up for an account and you can start trying CAD out. And there's many tutorials online that you can follow that go into the really in-depth descriptions of how you can sort of make all of these complex models and actually create them in real life with things like 3D printers and CNC machines and woodcutters and such. So yeah, I think that's pretty much about all I have to show.
I have
yeah.
a question about Tinkercad.
Mm-hmm.
Is it like possible to group shapes in any way?
Yeah, so I think so when I connected the top together, I was grouping those shapes. So if I would go back to here, I can, for example, group this component with this component with this component and select this icon right here, which is group. And I click on them, they're connected all together. And they're one
so do you have
solid
to shift
object.
and click them?
Yeah, shift click to select multiple objects.
Okay, got it. Thank you.
And then you can ungroup the objects by just clicking the button again, and then you can bring them back to its original form. So grouping is pretty useful when you want to 3D print parts because you want to actually make sure that all the components are combined into one solid object. And
So if it's not connected, would the grouping not work?
If it's not connected, it should still work, but it might be a little bit finicky because the parts are technically not really actually together. So when you throw it in 3D printer slicer, you might actually get some weird sort of combination between parts, but you'll have to try that out and your mileage will vary. So it depends. Yeah.
Okay, thank you.
Yeah, thank you so much for that great presentation and CAD project. I'm sure it was like as insightful for me as it was for everyone.
Yeah, I hope you all enjoyed it and got a better sort of perspective on how CAD works and engineering in general, and how there's a lot more to it than just building the parts from scratch with your idea from your head. So.
Yep.
Thank you very much for attending our event, everyone. Make sure to check out the video we will post of this recorded session on our YouTube channel, as well as our Facebook group, YouTube channel, and Instagram for more updates on future speaker events. And some helpful links have been posted in the chat.
Thank you
for joining.